Welcome to Mathematics with Larry. In this video, we will be looking at factorization of expressions. Now, the big question is, what is factorization? Factorization is a process of breaking down an expression into its simpler factors. In other words, factorization is finding the building blocks of an expression. Look at this example. 12 can be broken down into its factors 2 times 6. We can further break down 12 into 2 times 2 times 3. And when you look at the second expression of 12 into its factors, we can actually say that 12 has been expressed into its prime factors. Let's go further to look at some examples on factorization of expressions. Now the big question is, factorize the following and simplify them completely. 1. 7x squared plus 28x. 2. X cubed y minus x squared y squared. 3. 2ab plus 4ab squared minus 6a squared b. 4. 6ac minus 9a squared c all on 3a squared c plus 6abc. Now let's look at each one of them detailing. Now if we go into detail, we will see that 1, which is 7x squared plus 28x, can be expressed into its prime factors. Now, when we start off with the first factor or the first term in this expression, which is 7x squared, we can express it as 7 times x times x. The dots that we display here are multiplication, or they represent multiplication, such that we have 7.x.x plus 28 can be expressed as 2 times 2 times 7. Those are the prime factors of 28, because 2 times 2 is 4, 4 times 7 is 28. So we have 28x as 2.2.7.x. Now, this expression, furthermore, we have it as such displayed. And now when we look at the two terms that make up this expression, here are the two terms we're talking about. 7.x.x plus 2.2.7.x. We realize that 7 is a common factor to both terms. And since 7 is a common factor to both terms, we underline the 7 to highlight, that is to actually show that 7 is a common factor. If we look further both terms, we will see that there is another common factor, which is x. And so if we organize, and if in this particular expression, the common factors are organized such that they are at the extremes. Now, if we go further to the next step by introducing a pair of brackets, we can actually see that we can engulf what has not been used, that is x plus 2.2. That is what is not common to both terms. We can put it in bracket. And then we see that we have 7.x at the beginning and 7.x at the extreme. Now, in this situation, we can strike off one of the 7.x such that we will be left with just 7.x in one position. And then now, that factor, it will give us 7.x into x plus 2.2. And this will further give us 7x squared plus 28x being equal to 7x into x plus 4. And this is the complete factorized form of this expression. Now, we have factorized an expression of two terms to end up with a single term by introducing what? Brackets. Now, let's look at the second question. Now, in this second question, which is x cubed y minus x squared y squared, expressing it into its prime factors, basic factors, we have x cubed as x dot x dot x dot y. Then x squared y squared will be x dot x y dot y. And now when we look at them, we have common factors. What are the common factors? The first pair of common factors we have to both terms are x. Then the next pair of common factors we have still x. And then now the next is y. Now if we rearrange this expression such that we have the common factors at the beginning and also at the end of the two terms, we have this. Now introducing a pair of brackets to engulf what has or what is not common to both terms, we have just x minus y, or x and y as non-common factors. Now if we introduce that, we have it as such. Then if we strike off these other common factors to the right as we did earlier, we end up with that, such that this expression will end up as x squared y into x minus y. Now let's go to the next exercise, which is 3. Now if we look at it, we have 2ab plus 4ab squared minus 6a squared b, expressing it as a pair of that's expressing it into its prime factors. We have 2 dot a dot b plus 2 dot 2, that is 4 is expressed as 2 dot 2, then dot a, and b squared will be b dot b, while 6 can be expressed as what? 2, or can be broken down into 2 dot 2 and a squared into a dot b. Now we have these three terms expressed as their prime factors. Now with these factors, let's look at the common factors to the three terms. The first common factor to the three terms, we have 2, and then the next common factor will be a, and the next common factor is b. Now if we look at the first term, 2 dot a dot b, we realize that all the factors in this expression are common to the other two terms. All the factors in this first term are common to the other two terms. And so every term, we should note that every term in an expression has a factor which is always on display, which we do not always display it, and that factor is 1. So if we factor out these common factors, we end up with what? 2 times a, that's 2ab into 1 plus 2b, that is this 2 times b, giving us 2b, minus, here we have 3 and a, which were not used. So 3 times a will give us what? Minus 3a, such that this expression, when we factorize it, we get what? 2ab into 1 plus 2b minus 3a. Now 1, we have 1 here because 1 times what we have here times 2ab will give us what? 2ab. I think we can recall that any number multiplied by 1 gives us the same number. Now let's look at the next exercise 4. This one is a rational expression. That is, it has a numerator and a denominator. Now we will treat the numerator as an expression and also treat the denominator as another expression, but we should not forget the fact that they are linked by a division sign, which is this line. So at the numerator, we have some common factors. The first common factor in the pair of terms at the numerator is 3. Now the next common factor is a, and a third common factor is c. Now looking at the denominator, we equally have what? A common factor 3, we have a and C as well. Now, if at the numerator we factor out 3ac and at the denominator we factor out 3ac, you realize that at the numerator, for the first term, we have a 2 that is not being factored out, which is not common to both terms. And then to the second term, we have a 3a, which is not common, such that if we factor out 3ac, we have 3ac into 2 minus 3a, and at the denominator, where we also had 3ac as a common factor, if we factor it out, we'll end up with 3ac into a plus 2b at the denominator. But now, if we look at what we have here, this expression, we realize that 3ac is common to the numerator and is also common to the denominator, such that we can strike it off. And if we strike it off, that is, it will be like 3ac divided by 3ac, which is equal to 1. It's not actually like you are cancelling in, but you are considering based on the fact that 3ac divided by 3ac is equal to 1, such that this expression now will end up as 2 minus 3a all on a plus 2b. And so we have actually done what? Factorize those expressions. Please do take out time and look at these examples these other exercises that I have put up here. Take off your time, factorize them one after the other. Thank you for watching. See you in our next video. Bye bye.